This is CPM Calculus Chapter 6, number 96. So here we want to use the fundamental theorem of calculus to find the derivative of this integral. Okay, so remember the fundamental theorem of calculus basically tells us that the derivative and integral cancel out. But now we have additional rules now that we have the chain rule. Okay, because let's just do a quick reminder. If we have the derivative of, let's just say from a to b, right, of just f of t dt, right, if we're going to take the derivative of this, if we're going to take the integral first, this is just leaving the derivative on the outside. This right here, if we take the antiderivative, it's going to be big F, right? And since we have from a to b, it's going to be big F of b minus big F of a, right? And then when we take the derivative of this is going to be the derivative of this. It's going to be little f of b minus the little f of a. Okay, so this becomes f of b minus f of a. But now, the difference now is that we have, instead of the derivative of this basic integral, we have a more complicated integral. We have not just f of t here, we also have a and b no longer constants, but now they are actually functions themselves. So we could call this g of x and h of x. Okay, so here is the first one. Now our new thing, right? Let's keep the derivative there. Now this is going to be, again, big F, right? When we take the integral, it's still big F minus big F, right? But now inside of here we have g of x minus big F of h of x, right? These are functions inside, okay? So when we take the derivative of big F is still little f, right? It's still going to be little f of g of x, but it's going to be times the derivative, right? Because of the chain rule, times g prime of x minus little f with h of x in it, but it's going to be times h prime of x, okay? So the new thing is now we have to worry about if these here are functions, right? Then we have to remember the chain rule. Okay, so let's go ahead and look at our question. So when we take the derivative of this, again, that's just going to be the derivative of our integral, and I'm going to even write that as whatever it is going to be big F, right, of x squared minus big F of 3x. Right, this is basically just taking the integral, right? But now that we have to find the derivative of this is going to be little f of x squared times the derivative of x squared is 2x minus the little f of 3x times the derivative of 3x is 3. Okay? So our function, remember, is e to the t squared power. So if we plug in x squared as the input, it's going to be e to the power of x squared times 2x minus, now we're going to plug in 3x, so it's e to 3x squared power times 3. Okay? So if we simplify that, that just gives us 2x, I'm just putting this in the front, times e, if we square x squared, that's just x to the 4th, minus, put the 3 in the front. If we square 3x, that gives us e to the power of 9x squared. Alright, so the big thing to note is we have the chain rule, and that changes everything when we take the derivative of our big F's. Okay, so that ends for us CPM Calculus Chapter 6, number 96.